Welcome to the DIY Honda Garage channel. This presentation addresses the DTC P0113, which is defined as IAT sensor circuit high voltage, specifically applicable to the Honda Accord from model years 2012 to 2017. The intake air temperature, IAT sensor, plays a critical role in determining the temperature of the air entering the engine. This data is crucial for accurate engine performance adjustments and emissions management. Locating the IAT sensor, this component is typically integrated within the mass airflow (MAF) sensor assembly. Any malfunction with the IAT sensor can lead to improper fuel-to-air mixture ratios, ultimately affecting engine efficiency and performance. The high-voltage signal output generated by the IAT sensor is what prompts this DTC code. The detection of high voltage indicates a fault either within the sensor itself or in the associated wiring and connections, which necessitates a comprehensive diagnostic approach to identify and rectify the issue. The final repair verification is a critical step to ensure that all repairs and adjustments made have been successful in resolving the issue related to DTC P0113. Begin by securely reconnecting all connectors that were previously disconnected during the troubleshooting process. Once all connections are restored, utilize the HDS to exit the SCS mode, allowing normal vehicle operation to resume. After confirming the system is ready, switch the ignition to the on position once more to prepare the vehicle's systems. Following this, a reset of the PCM is crucial to remove any stored diagnostic trouble codes. Execute this reset through the HDS and conduct any necessary idle learn procedures as required. Finally, check the onboard diagnostic system for any remaining pending or confirmed DTCs. If DTC P0113 is indicated, it is vital to review the earlier steps, focusing particularly on connections. This verification solidifies confidence that any prior failures have been successfully addressed. To prevent future occurrences of DTC P0113, implementing proactive measures is essential for vehicle maintenance. Begin with regular inspections of connectors and wiring associated with the MAF sensor and IAT sensor to detect potential wear or corrosion. Ensuring that both sensors are properly mounted and secure will prevent vibrations from contributing to connection failures. An often overlooked aspect is keeping the PCM software up to date, as newer software versions can address known bugs and improve system performance. Continuously checking the integrity of the wiring harness can also catch issues early before they lead to more extensive problems. Finally, using genuine OEM parts during any repairs or replacements guarantees compatibility and reliability, minimizing the risk of similar DTCs re-emerging. A combination of these preventive actions will prolong the lifespan of components and enhance overall engine efficiency. In conclusion, understanding the implications of DTC P0113 is essential for effective vehicle maintenance and repair. This DTC indicates a significant issue with the intake air temperature sensor, which can lead to detrimental engine performance if not addressed. It is crucial to assess all connections associated with the IAT and MAF sensors to ensure they are secure and functioning correctly. Performing systematic checks can help pinpoint issues ranging from faulty sensors to damaged wiring, facilitating timely repairs. Updating or repairing components can alleviate the triggering of this DTC, while incorporating preventive measures will ensure longevity and reliability of the vehicle's systems. The key takeaway is that proactive approaches combined with thorough diagnostics, are necessary to maintain optimal engine performance and prevent future complications associated with DTC P0113. The IAT sensor's primary role is to measure the temperature of the air entering the engine. This information is vital for the powertrain control module, TCM, to adjust fuel injection and ignition timing accurately. The IAT sensor is typically located within the MAF sensor assembly, which is positioned in the air intake pathway leading to the engine. A high voltage signal above 4.92 volts indicates a potential malfunction that may cause erratic performance or increase emissions. When this signal exceeds the expected threshold, the PCM activates the DTC P0113 to alert the technician of a possible fault requiring further analysis. The complexity of this issue arises due to the potential involvement of the wiring harness, connectors, and the MAF sensor's parameters, making it necessary to conduct thorough diagnostics before arriving at a conclusion about the repairs needed. Several factors might lead to DTC P0113 being triggered. The foremost possibility is a faulty IAT sensor itself, which can distort readings and generate excessively high voltage signals. Additionally, poor connections at the IAT sensor or MAF sensor, such as loose terminals or corroded pins, can disrupt the circuit and lead to errors in the sensor's output. Damaged wiring, whether frayed, shorted, or completely severed, poses another significant risk, creating erratic signals that the PCM interprets incorrectly. In some cases, the PCM may itself present problems, but this is less frequent. Monitoring the circuit for intermittent failures, where the DTC may appear sporadically, is crucial to distinguish between genuine faults and temporary disruptions. Understanding these causes provides a foundational knowledge for the testing and troubleshooting steps that follow. The presence of DTC P0113 may manifest through various symptoms indicative of an underlying issue with the IAT sensor. One of the most common symptoms experienced by drivers is a noticeable decline in engine performance, potentially leading to a rough idle or engine misfires. Such misfires can trigger vibrations or unstable engine behavior, signaling insufficient or excessive fuel supply. Moreover, fuel economy may suffer dramatically due to incorrect air-fuel mixture adjustments prompted by faulty sensor readings, leading to overall inefficiency. Increased emissions can occur when the PCM compensates inappropriately for the incorrect temperature readings, risking the vehicle's compliance with environmental regulations. Finally, the illumination of the check engine light on the dashboard is a direct indication that malfunction and DTC have been stored in the vehicle's onboard diagnostic system, necessitating immediate attention. In the first troubleshooting step for DTC P0113, initiate the process by turning the ignition switch to the on position. If your vehicle is equipped with a push-button start, press the start button without engaging the engine. With the HDS or Honda Diagnostic System, you can begin to check the relevant parameters. Specifically, focus on the signal from the IAT sensor. You are looking for voltage values that should be more than 4.92 volts, which is the threshold indicating normal function. If the values match the expected threshold, this confirms the failure is duplicated, allowing you to advance to step 2. Conversely, if the signal does not exceed the threshold, you might be encountering intermittent issues or temporary signal loss. In such cases, it is essential to inspect for poor electrical connections or loose terminals associated with the MAF sensor, IAT sensor, and the powertrain control module, PCM. In this step, the focus shifts to diagnosing the connection integrity by testing the IAT sensor and MAF sensor network. Begin by turning off the ignition switch completely to ensure safety. disconnect the MAF sensor/IAT sensor 5P connector to isolate it from the PCM. After disconnection, a jumper wire must be used to bridge terminals A and B. Specifically, connect terminal A from the connector number 4, yellow, to terminal B from connector number 5, gray. Once the connections have been established, switch the ignition back on to the on position again. Utilizing the HDS, check the voltage on the IAT sensor. If the voltage still registers above the expected 4.92 volts, you can confidently move to step 3. Alternatively, if the voltage remains low, it suggests that the MAF/IAT sensor could be faulty, necessitating its replacement, followed by a confirmation of repair. After completing the previous checks, the third step in the troubleshooting process requires returning to the ignition off position before any disconnections can be made. Remove the jumper wire that was previously connected. Next, it's crucial to turn the ignition switch back to the on position to initiate further testing. At this point, you will measure the voltage between two test points on the MAF sensor/IAT sensor 5P connector and the body ground. Specifically, locate test point 1 from pin number 4, yellow, and test point 2 should be connected to body ground. You should be looking for an approximate voltage reading of about 5.0 volts. If you achieve this significantly positive voltage, the system should be considered functional, and you can progress to step 4. Conversely, a reading that indicates otherwise will require further investigation into the wiring and connections. Moving on to step 5. During this crucial fourth step, you'll perform an open wire check specifically on the SG2 line. To begin, switch off the ignition completely before proceeding. Then, utilize the HDS to jump the SCS line, indicating you are preparing to test continuity. Disconnect the MAF IAT sensor 5P connector at this point, ensuring to access the female terminal for the SG2 wire, pin number 5, gray, and the corresponding PCM connector, C51P. It is essential to check for continuity between these two specified test points. Continuity must be established under the condition of the ignition in the off position, which confirms the integrity of the SG2 wire. Should continuity be confirmed, the SG2 wire is determined to be intact, and you should consider updating the PCM with the latest software or substituting it with a known good unit before proceeding to repair verification. If continuity fails, this indicates an open circuit, requiring you to repair the wiring to restore functionality. In the fifth step of troubleshooting, you will perform a similar continuity check, but this time focusing on the TA line. Again, ensure the ignition is completely off before initiating the testing process. Activate the SCS line using the HDS, and then disconnect the relevant PCM connector B, 51P. The goal here is to check for continuity between terminal number 4, yellow, of the MAF IAT sensor 5P connector and terminal number 51, yellow, of the PCM connector B. Verify that both connectors are also disconnected during this test, which eliminates the possibility of false readings caused by linked circuits. A successful continuity test confirms that the TA wire is functioning properly. If the wire is intact, consider updating the PCM if it does not have the latest software, or substitute a known good PCM and proceed to the repair verification step thereafter. If continuity fails, take immediate action to repair the open TA wire for optimal performance. Please like and subscribe to the channel. See you next time.